Behavioral patterns. These patterns help govern the interaction between objects. The observer pattern defines a one-to-many dependency where, when one object changes state, all its dependents are notified. The two most common examples of this are delegates and events, though custom ones can also be created. The easiest way to think of an observer is, something happened, and now these are all the things I want to have happen whenever that action occurs. We start by defining the observer and decide on an appropriate time to either call it, if it's a method, or update its current state. A subject will have a list of dependents, often called listeners or subscribers. At some point, these get registered to the observer, usually when first created or enabled, and then later unregistered, usually when destroyed or disabled. When the observer is triggered, we loop through the list of all dependencies, if there are any, and notify them. More advanced uses of this pattern include event channels and event buses. Observers can be a powerful way to decouple code, since the observer acts independent of whether anyone is listening or how many listeners it has. However, memory leaks can occur if subscribers are not properly deregistered. The strategy pattern allows you to define a family of algorithms, encapsulate each one, and make them interchangeable. This pattern lets you select an algorithm's behavior at runtime, promoting flexibility and adherence to the open-closed principle, meaning open for extension, closed for modification. Strategies often begin with an interface or abstract base class, with concrete versions extending from it. The base is used as a placeholder in other classes or methods until a specific implementation is defined. The strategy pattern is one of the most powerful and most commonly used programming patterns. It's often employed in things like spell systems, weapon systems, interact systems, and anywhere else in which it's desirable to swap out behaviors of a given type without knowing exactly what they are ahead of time.
I'll tell you, personally, I pretty much am a strategy pattern guy, right? I think the strategy pattern really is the basis of all patterns, right? I mean, it's pretty much, life is strategy. That's pretty much just use an interface.
The command pattern turns actions into objects by encapsulating them. We start by defining a class or interface, such as iCommand. Typically, this will have an execute method that gets called whenever a command is invoked. Commands can then be gathered together into a collection, such as a queue, where they can be processed in a particular order and at a particular time. Commands can be repeated by queuing up multiple instances, or they can be cancelled by removing them from the collection without invoking them. They can also be sorted and recorded to produce things like undo-redo or replay functionality. One drawback is memory allocation if too many commands are stored. The state pattern allows an object to change its behavior when its internal condition changes, effectively letting an object appear to change its class. This is particularly useful for objects that need to behave differently based on context, such as a game character transitioning between walking, running, or jumping. States don't just apply to characters, they can apply to anything that changes behavior in response to changing conditions, such as a chest, a dialogue tree, a quest, a UI element, or an entire game. The simplest form of this pattern is a Boolean flag, wherein an entity switches between two states based on some condition. More complex versions include if-else blocks, ternary chains, enums, switch statements, and finite state machines. The template method pattern defines the skeletal structure of an algorithm inside of a function, but defers specific implementation to subclasses. For instance, in a particular class, we define a method that calls step 1, then step 2, then step 3 in that order. However, each step is marked as abstract and must be overridden. In a concrete class, we might define each of these steps a certain way, and then, in another concrete class, define each of them in a different way. We could even reorder the steps just by changing which one we define as step 1 and which one is step 2. The template method is sometimes used within the state pattern to define the various phases of a state, such as enter, tick, or exit. In Unity Engine, the mono-behavior lifecycle follows this pattern, wherein each phase occurs in sequence and can be overridden by a class that extends mono-behavior. One drawback of this pattern is that it's tightly coupled to the implementation defined in the base class. If we have unused steps, we can leave them empty, but we cannot insert new steps between existing ones, and must be mindful of the order of operations. Double dispatch. A process for choosing which method to call based on the runtime type of both the caller and the one being called upon, the latter of which appears as an argument in the method signature. Polymorphism is the principle by which a class can be treated as its own type or as its parent type, depending on context. For instance, all dogs are mammals, but not all mammals are dogs. Dog, in this case, extends mammal, and thus is polymorphic by virtue of inheritance. This can lead to behavior that varies dynamically and is somewhat unpredictable. Double dispatch ensures that behavior is chosen based on the type of both interacting objects, enabling flexible and dynamic operations without requiring prior knowledge of exact types. The visitor pattern. Separation of concerns means that a class should only be responsible for its own behavior and not have to worry about who or what it interacts with or when. The visitor pattern is a form of double dispatch that places the burden of responsibility on the visitor to determine what should be done during an interaction. This avoids creating an excess of references and is highly scalable as we can add functionality without modifying the underlying class. A visitor might have many different methods, depending on the type of object it interacts with, but doesn't necessarily know which one to invoke due to polymorphism, and the fact that a class could be one of multiple different types at any given time. The class being visited is given the ability to accept a visitor and return its exact type at runtime, so that the visitor knows which function to invoke. The bottleneck in this pattern is with the visitor itself, as it will need to be modified for every new type of entity that can be visited. It's best used when many new functions need to be added to existing elements, but the set of elements itself remains largely unchanged. The Iterator pattern. A way to sequentially access elements in a collection without exposing the underlying representation. For loops and for each loops are a type of iterator. In C#, the IEnumerable and IEnumerator interfaces let you define and iterate over such a collection while applying custom behavior in the process. Chain of responsibility. An algorithm that passes a request along a series of handlers until one of them processes the request. Start by creating an interface or base abstract class from which all handlers extend. The interface stores a reference to its next handler and defines a method that assigns it, as well as an abstract method whose signature determines what kind of information it can process. Child classes then provide a specific implementation for how they should process data sent to them. If a class is unable to process the information, it passes it to the next handler in the chain. This continues until the data is finally processed or the chain runs out of handlers. One downside to this pattern is that it can make debugging more difficult as information is passed between many points of contact, like trying to talk to a real person on a customer service hotline. The Mediator pattern. A way to centralize communication between objects to reduce dependencies between them. Managers, registries, lookup tables, and repositories all tend to implement the Mediator pattern, as any class that needs information can simply call them directly and ask for data or methods stored there. Events and event channels can also serve as mediators by notifying all subscribers when a particular action has occurred. Mediators are highly scalable as they help enforce separation of concerns. The Memento pattern allows you to capture and externalize an object's internal state, preserving it so that you can restore the object to that state later. This is useful for undo and redo functionality in applications, as well as replays and version control. In gaming and emulation, it can be used to generate checkpoints and death warps, as well as save states to preserve persistent game data or prevent soft locking. This pattern can lead to excessive memory use if many states are stored. The interpreter pattern. An interpreter's job is to provide translation between two languages, taking into account not just individual symbols, but also context. They can involve natural languages, programming languages, or both. If you've ever used a parser, such as int.parse or string.parse, you've encountered this pattern before, but it's possible to write your own. Indeed, the word parse means to analyze each symbol in a set and extract some useful value from it if possible. A dictionary can act as a lookup table for providing such translations. Depending on context, an interpreter can also perform some work on a value or set of values before returning a result. The retry pattern. A means of executing an action and retrying it a specific number of times if it fails. This is useful for working with unreliable operations, such as network requests. we define a number of attempts and loop over our action until we either succeed in the action we're attempting or run out of tries. A try-catch statement can be useful if you need to throw an error or exception, alerting the user that the process has failed repeatedly. Property Change Listener. A specific form of the observer pattern where subscribers are only interested in listening for changes to a single property, rather than to any and all changes that might occur. Usually this occurs in a property setter or at the end of a function. When the value is changed, all dependencies are notified. For instance, the value of a slider might be stored as a property, and then certain things happen when the slider is moved, and its corresponding value is modified. Specialized behavioral patterns. These patterns have more narrow use cases in terms of coordinating object behavior. The Event Aggregator pattern consolidates event management into a single object to help decouple publishers and subscribers. Start by defining simple classes to represent events. Next, create a central hub to register, deregister, and publish events. The event aggregator is often made into a singleton. The aggregator holds a dictionary whose keys are our event types. Each type then maintains a list of subscribers. Various systems can then call the aggregator inside their methods and tell it to publish events as they happen. Other entities and systems can then call the aggregator to register as subscribers to those events, passing in their event arguments. Some downsides are that it can make tracing issues difficult and is prone to memory leaks if subscribers aren't cleaned up properly. The Null Object or no-op pattern. A default do-nothing implementation of an object to avoid getting null exceptions or creating excessive null checks. Some objects can't be used unless and until they're initialized, for instance lists. To get around this, we create the default implementation and assign it when an object is initialized. This pattern is not useful if you actually need the object to be capable of being null, however. The black hole pattern. A form of null object in which all methods and properties of a class also have default do-nothing implementation. The result is to swallow or mute all such methods and properties without side effects or outputs. One drawback to this pattern is that it has the potential to swallow genuine errors and unwanted behavior as well if used improperly, making it less useful if you need to trace such behavior. The specification pattern. A way to encapsulate logic used for filtering and matching. Start by defining an interface for the type of object you wish to filter, and an abstract set of conditions to be met. Generics can be used for this purpose. Child classes will define a concrete implementation. For instance, a class that validates whether a person has reached a minimum age. We can then loop over a collection and filter out members that either meet or don't meet these particular requirements. The Role Object pattern. An object that takes on multiple roles dynamically, independent of its type hierarchy, similar to the strategy pattern and the concept of character class in role-playing games. We define an interface or abstract class for the role with an execute method. Child classes will define specific implementations for what it means to act in this role. A target object then creates an instance of this role, which can be invoked or changed dynamically. Injection patterns. These patterns help reduce coupling by providing a code block with the things it needs to do its job exactly when it needs them. They are a key part of clean code, allowing classes and methods to stand on their own as they don't need to know about the existence of other entities outside of exactly what's provided to them. Dependency Injection. The act of providing a class or method with all of its required dependencies, rather than relying on external calls or global variables. Dependency injection is a core part of functional programming, but can also be used to great effect in object-oriented programming as well. Many software applications have an inspector as part of its user interface. Physically dragging assets and references directly into serialized fields can also serve as a form of dependency injection. Constructor Injection. In object-oriented programming, a constructor is a special method that creates an instance of an object. Constructors serve as an entry point to a class and can perform initialization logic on an object. They're usually named the same as the class they define. When building a class, it's often essential to provide everything it needs right from the start. Constructor injection does exactly that, passing dependencies as arguments, often assigning them to local variables and caching them for later use. This approach ensures that the class has everything it needs to function and avoids runtime surprises. A constructor method can be overloaded, meaning multiple versions can be created with different signatures that have the same name, but different parameters for different initialization schemes. Having many dependencies or creating many overload methods could become unmanageable for larger or more complex classes. Setter injection. Sometimes flexibility is key. With setter injection, you can give a class its dependencies after it's been created. Setter injection allows you to swap dependencies mid-operation or provide defaults, keeping the design open to change. You can directly assign a value to a property or pass in a dependency as the parameter of a method. In either case, some logic can be performed on the value before it's finalized. By delaying the assignment of a dependency, this can lead to uninitialized or null values that could lead to errors or other unintended behavior if not addressed. Interface injection. A way to define a setter function in an interface or abstract base class, forcing any class that implements the interface to also implement the set function. While less intuitive, this can guarantee a class has a means of setting its dependencies. This adds complexity, but can be useful if you plan on overriding the specific implementation of the setter in child classes. If there are any design patterns you think we missed, let us know in the comments below. If you found this video helpful, please make sure to like, share, and subscribe so you stay up to date when we release new content. If you'd like to learn more about programming and game design, click on the link appearing on your screen now, or see the description below for ways you can help support this channel. Thanks, and take care.